Chavan, and welcome to this session. Today I'll be going through this code. So we'll be using TensorFlow 2.x, but instead of relying on Keras, we will build the neural network from scratch using TensorFlow's lower level functionality. By the end of this tutorial, you'll understand how to process the data, build a model, train it, and evaluate the result. Let's get started. Step 1 is to load the dataset. First step is to load the dataset, which is available in the CSV format. This dataset contains 150 samples of iris flowers, each characterized by 4 features: sepal length, sepal width, petal length, and petal width. The final column labels species contains the type of iris flower, setosa, versicolor, and virginica. Here's how we load the dataset using pandas. So this step makes it easier to work with the data in the neural network, as numerical labels are required for the model training process. Next, we'll separate our dataset into features and labels. The first 4 columns represent the features, the measurement of the flowers, and the last column is the labels, the species. We'll store the features in X and the labels in Y. This allows us to separately handle the input and target values for training the neural network. It is important to split the data into 2 sets, one for training the model and one for testing its performance. Typically, we use 80-20 split, where 80% of the data is used for training and the remaining 20% is used for testing. We'll use the train test split function from the sklearn model selection library to perform this split. This ensures that the model is evaluated on unseen data, helping us check its generalization performance. For multi-class classification, the label need to be one hot encoded. This means that each label will be represented as a vector with a 1 in the position of the correct class and zeros elsewhere. Since we have 3 species, our label will be represented by vectors with 3 elements. Here's how to convert the labels into one hot encoded vectors. Now comes the exciting part, building the neural network model. In this tutorial, we will design a simple model with 2 hidden layers. We'll build this model using TensorFlow level API, which gives us more flexibility in defining the network. There is 1, 2, 3 layers. Next, in the next step, we need to compile the model. This involves selecting a loss function and optimizer. Since we are working with a multi-class classification problem, we'll use categorical cross-entropy as the loss function and Adam as the optimizer. Adam is a very popular choice due to its ability to adapt the learning rate during training. Now it's time to train the model. We will train the model over 20 epochs using a batch size of 10. In each epoch, we will pass batches of training data through the model, calculate the loss, perform back propagation, and update model's weight. Once the model is trained, we'll evaluate its performance on the test set. This helps us understand how well the model generalizes to new data. We will calculate the accuracy, which tells us the percentage correct prediction. Now let's talk about how various parameters affect the model's accuracy. We use 100 neurons in each hidden layer, but changing the numbers of neuron or layers can have a significant impact on performance. If we reduce the numbers of neurons, the model may not have enough capacity to learn the patterns in the data, leading to underfitting. On the other hand, using too many neurons or layers can lead to overfitting, where the model performs well on training but poorly on new data, the unseen data. To prevent overlifting, we can use techniques like dropout, early stopping, or regularization. Sorry for that. So, yeah. So, yeah, that's pretty much it for today. Thank you for watching.